Hey everyone, welcome and thank you so much for joining this particular talk. Today we'll be talking about container security, and we definitely believe that it's the heart of our operations. I think that containerization is in general has kind of revolutionized the way we look at software development and deployment, and I believe that it has given us great powers, and we definitely believe that with great powers comes great responsibilities. So I feel that container security is one of those aspects that is now a critical component when we talk about building that resiliency and that kind of integrity of our day-to-day operations, right? So today we'll be exploring this vital aspect of container security, and we'll also be discussing some of the best practices that you can apply today itself in your particular organization, or even if we talk about your personal projects. Yep, my name is Kunal, and I am a community manager at the Cube Simplify community. I'm also a DevOps and open source advocate. That means I really love helping people out in getting started with it, getting started with open source and DevOps with whatever experience I have in the community. And I'm also a cloud native contributor. I've been involved in the CNCF ecosystem for around an year now, and I've contributed to projects like Kubernetes and Layer 5. Over to you, Siddhant.
Hey folks, I'm Siddhant Khisty. I'm a community manager at VMake Devs. I also love tinkering with computers, whether it's on the software layer or on the hardware layer. I also really love advocating for Linux and lots of different open source projects, and I love the freedom which they provide. Let's go next. All right, so this talk is about container security, but before we dive into the security aspect, let's first take a look at what exactly are containers and why should we even care about them. So first, what are containers? In very simple terms, you can think of containers as a way to package your applications along with all of their dependencies. So as you can see on the screen, we have a shipping container. Our software containers are also pretty similar. We just put our application code into this container along with the dependencies, the operating system, and whatever is required for it. And then we just send this container to the other person if you want to share the code or if you want to run it in production. Next. So we have many different tools which we can use for building containers. The most popular one of them, which is used by almost everybody now, is Docker. So Docker essentially enables us and it helps us to create containers in a way in that we can push it to a container registry and share it with other folks. We'll see what a container registry is in just a short while. But apart from Docker, we also have other options such as Containerd, which is essentially a lower version of Docker. Docker pretty much uses Containerd to create the containers. Then we also have LXC, which is Linux specific containers, and we have Cryo, which is containers for a Kubernetes environment. Next. So let's take a look at container architecture. Right here, I have two diagrams, but they are both the same. I'll explain it in just a bit. So for running a container, you first need your hardware, whether it is an ARM platform, whether it is an Intel x86 platform, or whatever. You need your hardware. On top of the hardware, you will add your kernel. In most cases, this is going to be your Linux kernel. Now, on top of the Linux kernel, everything else comes. So it could be a Linux based operating system, say Ubuntu, for example, or Arch Linux, or Red Hat, or whatever. And on top of that, we have an hypervisor. What exactly is a hypervisor? The most simple way to understand a hypervisor is that it is a software which is essentially going to which is going to talk to your kernel and request your kernel to allocate some system resources to specific containers. We need to note that in this entire container architecture, the only thing which can be considered virtual is the containers. Everything else is your physical hardware and your physical operating system. This Right now I explained a diagram on the left. The diagram on the right is essentially the same thing, but the only thing that we're removing from here is the operating system. So we're installing the hypervisor directly on top of the kernel. Next. All right, so before moving on to the security aspects, let's just understand what the container workflow looks like. Now let's take an example. Let's say that I have built an application in, say, Python using Django, and I want to share this with Kunal. Now I can use the traditional way. I can just push the code to a container registry, uh, Git registry such as GitHub, and then Kunal can pull the code and run it locally. But then this introduces the problem of dependency management. Kunal's computer might not have the dependencies which are required to run this application. He might not have Python installed, which means that he might not be able to run the application. So, in order to counter this, I will share it in the form of a container. So, I will take my Python application, I will create a container image for it. A container image is basically just a set of instructions on how the container should be created. So usually we will do this using a Docker file. Inside this Docker file we will mention all of our build instructions, and using this Docker file we will create this container image. All right. Now this container image will create the actual container which right now exists on my machine. I will push this container image to a container registry. A container registry is basically like a Git repository, but meant for containers. So Docker Hub, for example, or Google Container Registry. They have a wide variety of containers, both private registries and public registries, which stores hundreds of different containers. So now my job is over. Now Kunal will pull this container image which I have created, and he will have a copy of this same image on his computer, and he can use this image to create the exact same container which was on my computer, with the same dependencies, the same application. Over to you, Kunal.
Okay, thank you so much for sharing this, Siddhant. I think we got a really nice introduction to the overall container architecture and how actually we use containers in our day-to-day operations, right? So now from this section on, we'll actually be diving into each aspect of a container architecture, each component of a container architecture, and we'll also share some of the best practices that you can use to secure that. So the number one thing that comes to mind when we talk about containers is the image itself, right? The container image out of which the whole container is based upon, right? So let us first start with the image security, how we can secure a particular image and what are some of the best practices that can be followed there. So securing container images, why is it important? Now, what are we trying to achieve here? The goal is basically to build a strong foundation, right? So as I mentioned previously, everything starts from a container image. You are creating a container, you are running it, everything starts from actually using a particular image for that container. So it's essential to actually build a strong foundation. And as I mentioned previously, that images are actually the building blocks of a containerized application. So it's really important for you to consider the image security and use certain best practices to basically enhance your container image security. Now, if, for example, you're not able to do so, insecure images can very well lead to some kind of vulnerabilities, malware, and essentially outdated software components. And if you see the big picture, it can also lead to an insecure infrastructure and basically, compromise your entire kind of the architecture that you have built upon. So we can see that how important securing a container image is. Now, if you see this diagram, this is sort of a big picture of what you can protect against if you're securing your container image. If you have a secure container image, so you can secure from unauthorized access, data breaches, malicious code, compliance violations, vulnerability exploit, and many more of these. So this is sort of shows us quite a big picture of what we can protect our entire infrastructure from if we spend some time into this particular realm of securing our container image. Now, we discussed what, we discussed why should we secure. The important question is how we can do that, right? So here is when things get interesting. I'm going to give you a 5 questions checklist. So why I'm calling this a questions checklist, because we'll be asking questions for ourselves, and according to that I'll be giving you some action plans that you can implement on your organization. So basically those are some best practices that you can implement, and then you can directly see whether you are already implementing those or whether you want to implement those, right? So we'll be asking 5 questions from ourselves. The number one and the most basic when it comes to container image security is, Are the container images up to date? Now, when we talk about containers, we are essentially talking about tags in place of versions, right? So it's really important that you are using stable releases in terms of tags. Now, why I didn't go for latest releases? Because according to the research that we did from the various blogs and stuff, we came to know that the latest releases might have some kind of breaking changes in them. So it's quite a very safe option if you choose stable releases instead of latest one, right? And the next one is you should always check for available security patches or updates whenever you're choosing a stable, even you're choosing a stable release. You should always check for regular security patches or updates to your particular container images, so that you're always up to date with the security measures that has been taken by the company that developed that particular image. So it's really important, you should consider these points. Now, the next part is, are your container images scanned regularly? Now, I, as I previously mentioned, we are in a revolutionized period of technology right now, right? And new technology are being introduced daily, and that means there is a lot more room for new loopholes and new vulnerabilities to be to also be found, right? So it's really important for you to scan your container images and essentially your entire infrastructure regularly for new vulnerabilities or new loopholes to be found, right? So essentially you should be scanning your container images for potential vulnerabilities. You can use tools such as Kubescape, which is by Armo, which makes pretty much things quite easy when it comes to scanning your container images. And we'll be talking about tools a little bit later, but I just have to mention this particular one here. And once you have found these kind of vulnerabilities after scanning, it's really important to develop a kind of a process to address these kind of security issues, right? I mean, you have found the vulnerabilities. It won't do any good if you are not actually using those kind of information to actually deal with the security issues, right? So it's really important for you to develop a kind of a process to address these security issues as well. Coming on to my next question is, are container images verified? So I mean, it's evident from the question itself, you should always use the reputable and trusted sources to get your base images from the for your containerized applications. And it's always important to again verify the integrity and authenticity of the images that you're using. This has to be done before deploying, and it can also be done while you are in a testing environment. Before production, these all steps need to be followed in order to have kind of a safe environment and not used compromised images. Now, when it comes to verifying your integrity and authenticity, coming on to my next question is, how can we do that, right? So this is something called as, are the container images signed? So this is how you can verify your integrity and authenticity of a container image by attaching a digital signature with it by using the concept of image signing. And this can be done by using a tool like Cosign, which is a very famous tool by Sixstore, and it's completely open source, by the way. And this is how you can attach a digital signature, and you can verify whether the container image you are using is the one that was originally sent, or it has been tampered or has been played with in the middle of the transfer. And again, you have to you should definitely have some kind of a process in place to verify these kind of digital signatures and ensure the integrity of the container images that you're using. Again, if you're using a tool like Cosign, it will definitely help you there. The last but not the least question is a zero trust model being followed? Now, what do you mean by zero trust? Essentially is it's evident from the name that don't trust anyone. So all the users, whether that's in your organization or outside your organization's network, they have to be continuously authenticated and authorized before they access any kind of data or any kind of device in your particular ecosystem. So it's really important that you follow this kind of approach for even the users, any devices, any data, or the network that your organization is using. It's really important that you follow this kind of zero trust approach, so that you are secured even before you just start doing anything, right? And implement again, you have to implement strict access controls and some kind of authorization mechanisms, so that only authenticated users are allowed to access this kind of infrastructure. Now, this is something that is very general. I mean, the zero trust model is very very famous, very industry standard when it comes to the security aspect of cloud native, and it also applies to the container security aspect as well. Now, Let's move on to the image registry part. I mean, after images, we have secured the images, our images are secure, we have discussed the best practices. Now it's time for the place where all these images are stored, right? That is the image registry. So securing that is again even more important than the container images. So again, why? Because safeguarding, from unauthorized access and misuse, that's why we are implementing these kind of practices. It reduces basically the risk of deploying compromised images. Again, this is the place where we essentially store all the container images, right? So it becomes more and more important that we implement modern security practices to this particular container registry. Last but not the least is it ensures compliance and trustworthiness of the stakeholders that your organization is associated with, because they will know that you are actually implementing the security measures and you are potentially assessing the security risks that the image registries can be exported to, and you are constantly checking out for security vulnerabilities, or you're constantly checking out for the loopholes. So this is why it is really important to secure your container registries as well. Again, as I mentioned in the image section as well, this is how you can protect. This is the few areas that you can protect your image registry from unauthorized access, image tampering. I mean, the things are same, the idea is same as we compared it with the container registry, the container images, but the idea is container registry is the place that all the container images are stored, and it's become more important about when we talk about the security aspect of that. Now again, the question becomes how can we do that? So I'm going to give you again the simple format that we followed with the previous one, the 4 questions checklist this time, and we'll sort of discuss the best practices quickly with these 4 questions. Starting with the very basic one, is the image registry public or private? Now, one thing I would really love if you will all do is in the chat right now, everyone who's watching, you could very well, we are discussing these particular questions, we are discussing these best practices, so you can very well write in the chat if you are already using it, or if you feel that some best practices you can implement it in your organization. We would love to know that. So is the image registry public or private? So it is always recommended to use a private image registry that brings a lot more security and a lot more control in your hands if you're talking about private image registries. Nowadays, it's, to be honest, pretty simple to use that because we have a lot of cloud providers out there. Even Docker Hub provides it. We have Amazon ECR, DigitalOcean, and a lot of services are present that provides you with a private image registry as well. Now you'll ask, okay, Kunal, I mean, if I don't have the access of a private image registry, I'm sort of making my own personal project, or if I was very small scale organization, what can I do then? If the case is that you are using a public image registry, you definitely have to assess the potential risks that it brings, and you have to implement the security practices according to that, right? So if you're using private image registries, these sort of cloud providers actually take care of everything, but if you're using public, you have to do that manually, or you have to do that self-managed kind of thing. The next one is the image registry server secure? Again, this is one of the most essential aspect, and this becomes quite easy when you are actually using the cloud providers that I mentioned and different services that are already exist. If you're using those, this becomes more simpler because everything is being managed by them, and you just have to grant access and give permissions and those granular permissions that we just talked about. So it becomes quite easy. The main idea is you should restrict network access to the server. There should be only authenticated users being able to access your particular image registry server, and regular patching, hardening, and monitoring should be done of the registry server again and again. This becomes much simpler if you're using the tools that are already present, like I mentioned previously. Are access controls properly configured? So this is a really nice meme that depicts this particular question, managing access manually, and you should always go for something like AWS identity and access management for managing your access. So the idea is basically you have to give granular access controls to the operations like push, pull, and modify the images. Now by granular, I mean you should always follow a least privilege model. By least privilege By least privilege model, I mean only give the access that is necessary, not more and not less, right? You might have heard about this least privilege model in the security space as well. This is the number one point. The next one is again setting up a necessary authorization mechanism to allow only authenticated users. Again, if you're using something like AWS IAM, this becomes much simpler, and there are a lot of other services that grants you this kind of functionality to be able to implement in your organization. Coming on to my last and not, but not the least, and one of the most important ones, I would say, is again vulnerabilities. Are they being monitored? So this is something which is quite similar to vulnerability scanning. So you constantly have to scan for new vulnerabilities. This was something common with container images. It also implements in container registries as well. So regular monitoring of the stored image is very essential, and you can always integrate a tool, vulnerability scanning tool like Trivi, which is by Aqua Security, a very famous tool out there. Again, it's open source, so you can use it. And the idea is basically you have to continuously monitor for new security loopholes or new security vulnerabilities. That is something that was common with images as well. Over to you, Siddhant.
All right, cool. Thanks for all that information, Kunal. That covers most of the important points on how you can secure your containers. Now let's talk more about the entire build process itself and how you can configure configure your containers in a secure manner. Most insecurities that arise are usually due to some sort of misconfiguration. So first, let's take a look at this. Next. So in your Docker file, what you usually do is you start out with a base image. This base image can be anything. It can be an Ubuntu image, it can be a Node image, anything. After that, you usually copy your application code into the container. Then you would add your environment variables, any extra configurations, scripts, whatever. And then from that, you would finally build your container image. So that is how you would use your Docker file. Now let's talk a little bit on how you can secure it. Next. So the biggest red flag in any sort of build process that you need to keep an eye out for is privilege escalation. Privilege escalation basically means that you're giving your container root access, which is not a good idea in any scenario. Because then, if any malicious parties get access to your container, they will have root access. And since we already saw that your containers are running on top of your existing host kernel, there is a chance that the attacker can find some sort of way to attack your kernel itself. Next. Another thing is you need to reduce the attack space that malicious actors can use. So, for example, let's say you have an Ubuntu image which is around 300, maybe 400 MBs. So you have so much of space where your attackers can find a vulnerability and latch onto that to get into your system. So this is where using lightweight images can help. Another uh, another way to reduce your attack surface is by using multi-stage builds. So if you take a look at this Docker file right here, we're doing it in two stages. In the first stage, we're using Ubuntu 16.04 as our base image, and we're running all of our updates in the container. And in the second stage, we are using an Alpine image as the base image, and we're copying everything from the first stage. So all the tasks which we have run, which needed the dependencies of Ubuntu, we are copying them into the second stage. Next. All right. So why exactly we're using Alpine? So if you look over here, I've just pulled the Ubuntu image and the Alpine image, and look at the size difference. The Ubuntu image is 135 MB, while the Alpine image is just roughly 5.5 MB, which is like a huge difference in terms of attack surface. Next. All right, now we've talked about the build process. Now let's talk about securing your host operating system. Next. So we already discussed that why is the uh, host host security important, because your containers are basically running on your host hardware itself. We're not virtualizing the hardware like we would do in a virtual machine. Instead, we're using the host operating system, and we're creating containers, which are the virtual things. Now basically we have two concepts in containers: C groups and namespaces. Namespaces basically isolate the container processes, so similar to how chroot does it. But please note that in containers we use something called as pivot root and not chroot. You can check that out later. And the second thing is C groups, which is used for resource allocations. So C groups will basically tell the kernel to get a certain amount of system resources from your hardware layer and give it to our containers. Next, one way that we can reduce the host OS vulnerabilities is by, again, using a lightweight host OS. So basically reducing the attack surfaces. So we have many options for this. We have Alpine Linux, we have Debian, we have Arch Linux. And in my very biased opinion, Arch Linux is probably the best because you pretty much can configure every single element of it. Next. All right. Once we have a lightweight image, we also want to make sure that no unwanted parties have access to the host operating system as well. So for this, we would need a pretty robust access control system. So for this, we can prevent network accesses using something like firewall D. And for the host operating system security as well, for a Linux based system, we can use something like Security Enhanced Linux or SE Linux, or we can use App Armor as well, which is one of the de facto security modules for Linux. Next.
All right. Thank you so much for sharing this, Siddhant. Really, really useful. And I think this is one of the most interesting parts, at least for me, from the entire session, that is talking about tools. So we discussed a lot of nice practices that you can follow in your entire container architecture, different aspects of it. But these kind of the tools that are already out there, especially the open source tools, those actually make your lives pretty easy to use these kind of practices in your day-to-day operation. So let us quickly see that. Now, before moving on to the tools, we can quickly see like how to actually choose a kind of tool. What are the parameters that you can consider before jumping on to actually choosing a particular tool which adheres to the principles of your particular organization? So these are a few things that you should always consider when you are kind of choosing a tool. One is vulnerability scanning. Again, I mentioned always regularly scanning for known vulnerabilities or unknown vulnerabilities as well. That is pretty essential when we're talking about different aspects of a container architecture. Image integrity and verification, there should be some kind of a process to actually verify your images from one data point to another. This can be done through image signing, as I mentioned previously. Runtime security is something that we didn't cover in this particular talk, but again, this is something very important. Monitoring your container activity during runtime, how is it behaving, and whether you found any bug or any errors or any kind of security vulnerabilities through runtime. So you definitely have to see that that kind of tool is actually monitoring your container activity during the runtime. The last but not the least is the compliance and audit capabilities. Is the tool capable producing compliance and audit logs? Is it following some kind of security benchmarks such as CIS benchmarks that we have in the security ecosystem? So these are some of the points that you can always look for, or the parameters that you can always look for before deciding any tool which is right for your organization. So these are sort of the tools that are spread across the entire open source ecosystem. These all are open source, and you can definitely use them in your day-to-day operations. So we have Clear, which can be used for static vulnerability analysis. We have Sysdig, specifically Sysdig Secure, which can be used for container runtime security. We also have something called as SNCC containers that you can use for vulnerability scan and monitoring. I actually have used this hands-on, so it's pretty awesome. You should definitely try it out. You have Cosign, very famous project by Sixstore for image signing. Kubescape by Armo is again a very nice open source project which can be used for vulnerability scanning for images as well as image registry as well. Falco is a CNCF incubating project which can be used for again runtime protection. And last but not the least is Trivi, which can be used for vulnerability scanning of your images as well. Now these are a few tools. If you are already familiar with some of the tools and you are using them in your organization, we would love to hear them in the chat as well. And yep, we can have a discussion there. Okay, we are about at the end of this session. We talked about a lot of stuff, so let's quickly go through it, and let's summarize it a bit. So we talked about email security, registry security. We talked about after that. Then Siddhant told you about securing the build process, which is pretty important. Host security, which not a lot of people talk about, I believe, and we covered that as well. And at last, not but not the least, my favorite section was tools that makes everything a lot easier. And these, if you're watching it live right now, or even if you're watching a recording after that, you can scan this particular QR code. We have compiled a list of resources that you can, you know, refer to learn more about container security and sort of another other best practices that you can implement in your day-to-day life at your organization. Again, thank you so much everyone for listening so patiently. I hope we didn't go over time, but have a good day everyone. Thank you.